Hey guys, this is going to be a video on 2.2 homework. In this one, we're going to be taking transformations, or we're going to be applying transformations to functions. Okay, so write a function g. That just means that the new function that we're going to be writing is going to be named g of x. Okay, for all of these, we're just going to call the new function g of x. Okay, whose graph represents the indicated transformation of the graph of f. So we're starting with this function right here. Here's what we're going to do to transform it. So we need to apply this to this right here. This one is x minus 5. It's a linear function that is down 5 units from its parent function. And then we are going to do this to it. We're going to translate it 4 units to the left. So the rule for that, if we're going to translate something to the left, that's horizontal. So that means inside parentheses, we're going to write the x value, and if it's to the left, that means we're going to add. So x plus 4. So right here where there's an x, we're going to write parentheses x plus 4. Don't forget that we also have the minus 5. And then we're going to simplify. Now, because nothing is being multiplied around this right here, this is not indicating multiplication. This is just indicating subtracting of 5. And so I don't need these parentheses. So imagine they aren't there. So I have x plus 4 minus 5. I can simplify that to be g of x is equal to x minus 1. And there we go. We have our function. Just to kind of show you that this checks out, let's go to Desmos. Okay. So we had x plus 5, correct? I think that's what we had. Or was it x minus 5? It was x minus 5. So x minus 5. And then what we did was did x moved to the left plus 4 and then minus 5. And what this is doing, we were supposed to move it to the left. So the red one was what we started with, and you can definitely see that it's being moved to the left 4. Okay. You can also see that the y-intercept of the new line, after we simplify it, the blue line, is supposed to be at -1. And that's what we end up with. The new intercept is now going to be -1. Because moving it to the left also moves it up as well in a kind of a different way. So moving it to the left was actually the same thing as moving it up. Okay, let's see right here. So f of x is equal to the absolute value of 4x plus 3, close absolute value, plus 2, translation 2 units down. Okay, so the translation, this is what we're going to apply to this one. If we're going to move it up or down. That's a vertical translation. So we're going to take the function, the y values of the function, and we're going to subtract 2 from it. Remember that all of this represents all of y. So I'm just going to copy that down exactly as it is, plus 2, and then at the very end, I'm going to do the minus 2. So remember, this right here is all the y values minus 2. Remember, f of x is y, so y minus 2. We just took all this, y minus 2. Okay, now we just have to simplify it. So those values right there, we can combine. Remember that we can't combine these with any values inside here. These have to be kept alone. So plus 2, minus 2, those are going to cancel. So we're going to end up with g of x is equal to the absolute value of 4x plus 3, and then nothing on the outside. So this function right here from its parent function was up 2, but then we shifted it down 2, which would make sense. So now there's no vertical translation from the parent function. Question 3. We have this function given here, and we want to do a reflection across the x-axis. The rule for that, or how you apply the transformation, is to take the y values, or f of x, and multiply it by a negative. So let's write g of x now. G of x is going to be equal to, I'm going to first start by writing this part, the negative, and then I'm going to multiply all the y values, and all the y values are -5x plus 2, like that right there. And now I just have to distribute to simplify, and then this is going to give me positive 5x minus 2. There we go. A common mistake is that people don't write the parentheses right here when they're multiplying by a negative, and therefore they forget to distribute, which means this one will change signs, but then they forget to change the sign on this one. So watch out for that. A reflection in the y-axis. The rule for that is f of negative x. So f of negative x, what this is doing right here, so because it's a reflection in the y-axis, we want to flip all the x coordinates of the function, as opposed to the x-axis where we're trying to flip all the y coordinates of the function. Okay, so a reflection in the y-axis will mirror it across the y-axis, flipping all the x coordinates. So I just want to multiply x by a negative. So whenever I do that, I'll have a new function g of x, and that's going to be equal to the absolute value of 6. I'm going to multiply this by negative 1, and then minus 2. And then I'm going to look to simplify, because that can be simplified inside here. So if I have 6 times by negative x, that's essentially what we're doing, this will just become absolute value of negative 6x minus 2. Okay? But just to kind of bring back the whole idea right here, if this right here is negative, so think about it like this right here. If that's a negative inside this absolute value right here, and we're not adding or subtracting anything, well, so if I plug in negative 1, then this will become 6, and the absolute value of 6 is 6. If I plug in 1, this will become just negative 6, and the absolute value of negative 6 is 6. And if I can pick any other value, so if I plug in 2, that will become negative 12, and then the absolute value of that would just be 12. But if I plug in positive 2, then this, so if I plug in negative 2, it would be 12. If I plug in negative 2, it will also be 12. So this negative doesn't really need to be there. I can simplify it because it doesn't matter. It's always just going to be positive. So I can even write this as the absolute value of 6x minus 2. Okay, question number 5. A vertical stretch by a factor of 2. Vertical stretch by a factor of 5. Okay, and to apply the vertical stretch rule, you take the value that you're stretching by and you multiply it by all the y values, or all of the function, because the function is all the y values. So g of x is going to be equal to 5. And then in parentheses, because I'm multiplying and I might have to distribute, it's going to be 5 times by all of the function, x plus 2. All of this indicates all the y values. So f of x, just like I'm substituting it in, kind of like that right there. I'm going to multiply that. So that means I'm going to have to distribute because there are more than one terms. There's 2 terms here, 1 and 2. And so because there's more than 2 terms, this is going to be, have to distribute it to both. So this will be equal to 5x plus 10. And there we go. For the next one, a vertical shrink by a factor of 1/2. This will be the same. We're going to apply the same thing that we did in the previous problem. A vertical shrink or a vertical stretch, you do the exact same thing. So we're going to do 1/2 times by f of x. So g of x is going to be equal to 1/2 times by all the function, which in this case is going to be 2x plus 6. And we're going to distribute the 1/2. So then therefore g of x is going to be equal to, when I multiply 1/2 to 2, that's going to be 1. Those are inverses of each other. And so when I multiply them, they'll just be 1. So it's just going to be x. And then 1/2 times by 6 is going to be equal to 3. And there you go. We did a shrink by 1/2. For 7, this one has 2 transformations, and make sure that whenever you have more than one transformation that you do them in the order that it lists them. So the first transformation is a vertical stretch by a factor of 2. So the first transformation is going to be f of x vertical stretch by a factor of 2, sorry. That's going to be 2 times by f of x. So let's apply that transformation to what we have here. So we have, we're going to write this as g of x. G of x is going to be equal to 2. I'm not going to write parentheses because there's only one term. I'm just going to write 2x. Just that simple. So this right here is the parent function, and if I want to stretch it by 2, just multiply it by 2. Okay, now the next transformation followed by a translation. So this is going to be the second one. Translation up 1. So that's going to be f of x plus 1. But you're not going to write this function right here. Because we're going to add this transformation to what we just did. And so this right here is going to take on 2x, and then we're just going to add 1 to it. So then the next step would be g of x is equal to the function that we currently have, and then we're going to add 1 to it. So plus 1. And there you go. We just applied both those transformations. For 8, we have the same function right here. We have 2 transformations. The first one, translation 3 units down. So the first transformation is to take the function and subtract 3 from the y values. So let's do that here. G of x is going to be equal to take the function, which is x, and then we're going to subtract 3 from that. Okay, the next one, 2. Vertical shrink by a factor of 1/3. So that's going to be 1/3 times by the function that we have. And in this case, our function is x minus 3. So make sure you use parentheses around this. So we're going to have g of x is going to be equal to 1/3 times by all of the function. And then let's not forget that we have more than 2 terms now. So we're going to have to distribute the 1/3. Okay, and then that's going to be, I'm just going to write it as 1/3 times by x. You could write it as x over 3 divided by 3, that's fine too. And then when I do 1/3 times by 3, those are inverses of each other when it comes to multiplication. And 1/3 times by 3 will just be 1, so minus 1. So that right there is g of x. Okay, so hopefully that covered any problems that you didn't know how to do, and hopefully you guys found this video helpful.